Okay, here we go. This is section 7.2, and it's called graphing rational equations. Functions, not equations. Functions. Graphing rational functions. And really, this is, there's 3 different ways to do this. And so I'm thinking that we have 3 days of lessons left. So I'm thinking that we might just do 1, 1, and 1. And then that'll be, actually, we have 4 days of lessons left. Maybe 3 days. We'll see. But mostly we'll focus on this, and then we've done everything that we really needed to do in the textbook. Okay, so what we have is we have an equation like this, y equals 1 over x. And we haven't graphed it before. So we want to graph it. So we have to think of some values to substitute in. Okay, so if we don't know what values to substitute in, or if we don't know what a graph looks like, what are our normal ones to substitute in? What are our normal numbers to substitute in? I'll look in the chat window to see if I'm going too fast. So what numbers do we plug in? Hey, puppies. Oh, you don't need to cry. So what do you think? What numbers? Okay, so we're going to substitute in 1. And we're going to substitute in 5 numbers. So what, maybe 0? And what are some other numbers? Yeah, 2. And then can we do negatives? Let's see, -2, -1. Okay, so these are our normal numbers to substitute in. So let's see. So we're going to substitute them in individually. So this is 1 over -2. So I'll write this over here, but 1 over -2. So it doesn't matter whether the negative is on the top or the bottom. So usually people just call that -1/2. So we'll just call it -1/2. I'm going to do a slanty fraction just because I made my squares too little. Okay, so -1/2. 1 divided by -1. Remember, the bar means divided by. So 1 divided by -1, it's -1. 1 divided by 0. Let's procrastinate that one. 1 divided by 1 is 1. And 1 divided by 2 is 1/2. So 1 divided by 0. So that means 0 times what number equals 1? 0 times what number equals 1? Well, 0 times 0 is 0, and 0 times 1 is 0. Yeah, it's none. So this is nothing. Okay, so what we're going to write here actually is we're going to write ASY MPTOT. Over here I can put, it's called undefined. It's called undefined. So we're going to actually have an asymptote at 0. And this is the basic graph. So we're just doing the basic graph. So this is a new basic graph, basically. Okay, so let's see what we have. And then we're going to substitute some more numbers in just so we can see how it behaves. So let's graph what we have so far. Okay, I'm gonna shut the door here so use it. So graph those dots, okay? And then I'll be there's just the music on outside. Oh, there's my puppy though. Say hi. You want to say hi to Becky and Miss Brown? I don't know. You don't know they're there, huh? Okay, so let's see. So -1, -2, -1/2. So that's going to be right there. -1, -1. Asymptote, okay. 1, 1. 2, 1/2. So right now that's not enough points to know what shape it's going to look like. I mean, I could connect those points in any arrangement. So I'm going to write here extra. Okay, so we're only graphing these extra points because we don't know what it looks like. Now later we're going to memorize it. Thank you. Thank you for the blessing. Okay. Okay, so let's see. So this is what I call graphing with curiosity. You're like, I have no idea what it looks like, but I'd like to know another section of the graph because these 4 points, I don't see how they're going to be connected. So let's start with, I guess, 3. So let's wonder what happens if I substitute in 3. Well, that's 1/3. Okay, so that's 1/3. And 4, 1/4. Okay. So are there any numbers over there that are going to make me go below the x-axis? Am I going to get a negative if I plug in these positive numbers? 4, 5, 6, 7, 8, 9, 10. I'm not. You're right. Am I ever going to get to 0? Now, if I, yeah, no, I'm not going to get 0 either. So what happens over here, so I'm just going to draw this part of the graph right here. So what happens to the right is it hugs the x-axis. So actually that's another asymptote. These problems, they have 2 asymptotes in them. They have an asymptote within the table itself, and then they also have an asymptote that's a horizontal asymptote. So it's very interesting what you have. Okay, so that's what that part of the graph looks like. So then I'm curious what happens in this section. So let me just highlight, then I'm going to erase. But I want to know, well, what happens right here? Be kind of between -1 and 1, or 0 and 1 is where my yellow is. So I want to know what happens in here. So I have to think, okay, well, what number is right here? I know this one's 1, but maybe I should substitute in a half. Okay, so let me substitute in a half. So that would be 1/1/2. And that's 1 divided by a half. And divided by means you have to flip the second one. So that'd be 2. So 1/2 gives me 2 in the yellow. Okay, so what about 1/3? So 1 divided by 1/3 is 1 divided by 1/3 this way. And you flip the second one, 3. So 1/3, 3. Okay, so that's the asymptote right here. That's going to be another asymptote. So these graphs have 2 asymptotes. They have an asymptote that's a vertical asymptote, and they also have a horizontal asymptote. Oops, somehow I erased this part. One of my algebra classes, or my algebra 2 classes, called this the boomerang. So they called this one the boomerang. Okay, so that's 3. Now, if we memorize what the picture looks like, we'll still only need to graph our main points. So that's going to be our plan. So we're not going to graph all the points all the time. Okay. Now we need to figure out, well, what happens on the left side? Okay, so what happens if I substitute in a -3? So 1 over -3. Okay, that's -1/3. So -3 is -1/3. And then -4 would be -1/4. Okay, so that looks like it hugs this other asymptote, or the x-axis. It looks like it hugs the x-axis. Okay. And then I have some curiosity again, which is what happens in this section right here. So I want to know what happens over here. So the only thing I can do is substitute in x values in that section. So I'm going to say this value right here, this was -1. So that looks like it's -1/2. So I'm going to substitute in -1/2. So 1 divided by -1/2 is 1 divided by -1/2. 1 times -2/1, which is -2. -2. So -1/2 gives me -2. Okay, so which way do you think that one goes? What do you think? What direction? Yeah, that's what I'm thinking. I think it goes down. And then it hugs the asymptote. Okay, so our plan is not going to be to graph all these points. So these are all extra points. Let me label the word points. So these are extra points down here. So let's just draw another little sketch and see how we're going to memorize our points. We have 1, 1, 2, -1/2, -1, -1, -2, -1/2. But if I knew where the asymptotes were, if I knew where these asymptotes were, and I remember it kind of looks like a boomerang, then maybe I could graph it with just those points. And in fact, maybe I could just graph it with 2 points and not 4 points. This is actually 4 points. So the plan is to graph it by memorizing the graph is a boomerang. So 1 over x is a boomerang. And then trying not to graph too many points. So it has, this is like a boomerang and it has asymptotes. Okay, so that's our plan. And we're going to move it and shift it and all that and find out other asymptotes as well. And then this one has a lot of characteristics, but we're not going to do the characteristics today. We're just going to do the graphing. Let's see what they look like. Okay. Ready for the next one? Okay. Okay. So the next one will graph y equals. Okay, let's graph, we'll graph 6. Let's graph it with 1. We'll graph 1 over x minus 2 plus 4. So our basic graph is y equals 1 over x. And we're going to actually use the 1 that's in the numerator of our basic graph. So if that said 3 over x minus 2, we're going to put a 3 on the top of the over the x. So we'll see how that works. Here, Becky, look. Oh, right there, my other little puppy. Oh, and then the other one's coming. She's just behind me. Lots of kisses. You guys gonna learn math? You want to learn how to graph? Okay. So what do you think the 4 does? What do you think the 4 does? Think it moves it right, left, up, down? What do you think? Yeah, yep, it moves up 4. Okay, so this is going to be considered outside. So this is going to be an up 4. So by process of elimination, this one is inside. So I'm going to put in the denominator. We'll put in the denominator is inside on these. Okay, so if that's considered inside, then which way would the 2 move it? Yeah, so this would be right 2. You're exactly right. Okay, so what we're going to do is we're going to do the basic table, but we're going to do it for 1 over x. So we're not going to substitute it into the main equation. Tomorrow we might substitute it into the main equation, but today we're working on transformation. So you could practice memorizing what the graphs look like. -2, -1, 0, 1, and 2. And then there's another asymptote. Okay, so there's going to be a second asymptote. So down here we'll put HA for horizontal asymptote. Okay, this one's actually the VA. That one's the vertical asymptote. Okay, so 1 over -2 is -0.5. 1 over -1 is divided by, that's -1. 1 over 0 is called undefined, but that gives me an asymptote. So there's going to be a vertical asymptote at 0, at x equals 0. 1 over 1 is 1, and 1 over 2 is 0.5. And then there's going to be a horizontal asymptote at y equals 0. That's the normal one. Okay. And maybe what we could write is we could write the word asymptote again. So there's going to be an asymptote at 0. We'll call it H. H asymptote for horizontal asymptote. So there'll be a horizontal asymptote at 0. So the basics of this graph, what are we moving it up and right? Okay, so I should start low. So the original asymptotes are good to draw in at the beginning because they provide the structure of the graph. So there's an asymptote at y equals 0 and an asymptote at x equals 0 for the basic boomerang graph or the basic 1 over x graph. Okay, so those red dashed lines, the asymptotes, are going to be important for the structure so that I don't need to substitute in 10 points like I did over here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I substituted 11 points. I definitely don't think substituting 11 points is going to be a good plan for the future. Okay, so then this one is -2.5, -0.5, -1, -1, 1, 1, and 2.5. And then I'll draw it in dashed because we're going to move it. Okay, now the key thing on these graphs is the asymptotes. So you're going to move the and then we did that when we were doing logarithm and exponential graphs as well. So move the asymptotes first. Okay, the moving the asymptotes is providing the structure. And that's the part, along with the memorization, that gives you the best thing. So I'm going to graph my new asymptotes in, I don't know, I guess green. I wonder what color you would see the best. I guess we'll go with green. I think light green will be too light. Okay, so I'm going to move the asymptote. So the vertical asymptote, and actually look at the. I wonder if you guys can look at the photo of me. Oh, you know what? If I turn this volume on for just a second. Okay, so it's not going to work. Okay, because it keeps wanting to. It hears my voice on the other one. Let me see if I change my voice over here. Oh, I'll just do it on this video instead. I'll do it on the presenting video. Oh, I'll stop presenting for a second. Okay. Oh, but the video's not on. Let me change the video. Okay. So, oh, I think it's looking at my other video. There we go. Okay, so here's my, let's see. How can I not? Oh, there. I wonder which. Let me turn this video off so I'm not confused. Okay, here we go. So this one right here, if it's a vertical asymptote at 0 and I need to move it to the right, okay, so vertical asymptote and I move it to the right, the asymptote actually moves. What's interesting later on is if you have a vertical asymptote and you move it up, nothing happens. It turns out to be the same line. So like if it was at my nose, which it looks like right here, if I moved it up, it would still stay. Okay, but if I had a horizontal asymptote and I move it up, then that's going to change locations. Okay, so physically you're going to see the asymptote move. So the asymptote, one of the asymptotes starts at 0, x equals 0, which is the y-axis, and you're going to move it to the right. You're going to also move it up 4, but that doesn't really affect that asymptote. And then if you're going this way, okay, so this way, if you move it up, you're going to be able to tell the difference. But if you move it to the right or to the left, then you won't be able to tell the difference. Okay, so here, let me go back to presenting so we can see how that looks on the screen. Undo this. Go back to present screen. Go back to my OneNote. Here we go. So here's the asymptote. Okay, so the vertical asymptote, I'm going to move to the right. So this is its new location. I move it to the right. Okay, I'm moving the asymptote to the right and up, but up doesn't really affect a vertical asymptote. And then the other asymptote, which is sitting there on the x-axis, okay, this other red one right here, I'll highlight it. So this one right here, I'm having that one move up 2, I'm sorry, up 4 and right 2. So the right doesn't really move that yellow line. What it does is it just goes up, and then I'll erase the yellow line. So it's gonna, I'm sorry, it's not up, it's up 4. So it's gonna move up 4. And there'll be a new asymptote here. So the yellow moved to the green, and the blue, I think this highlighting will help you. You don't have to highlight yourself, but the blue moved over to become the green vertical asymptote, and the horizontal asymptote moved up. Okay, so the yellow moved up. It also moved to the right, but it doesn't really do anything. And then the blue vertical asymptote moved to the right too. Let me erase the, see if I could erase the, oh, it's not letting me erase the highlighting. Let's see. There we go. There we go. Okay. So now we're just focused on the green. We also need to move the points. I usually only move this point. I don't usually move the fraction point. I usually just move the whole number point. Okay, so that point needs to move to the right 2 and up 4, to the right 2, up 4. And then it has its boomerang right here. And then this point, I move to the right 2 and up 4. It lands right here, and then I have this boomerang. And then that's what your final graph looks like. And then this one is called the horizontal asymptote, the one that's the horizontal line. And that's going to be called y equals 4. You have to have the y equals to indicate that it's horizontal. And then the vertical asymptote, I'm writing on the bottom next to the vertical asymptote, is x equals 2. And I'm getting that information from my picture. So basically all the homework is going to be is to graph and label the horizontal asymptote and the vertical asymptote and write the equation. Any questions so far? Okay. So we're good? Okay, so let's go to another one. Okay, so the next one, we're going to change a couple things. I'm going to change the numerator to be a different number and also a different sign, just in case we run out of time. So let's do -2 divided by x plus 3 plus 1. Okay, so this still moves it up 1. And this inside moves it left 3. But my basic graph is going to keep the 2 in it. Okay, so instead of, I don't know what the 2 does. The negative was about flipping, but instead of worrying about what these two things do, I'm going to keep them in the basic. Okay, so I'm going to keep that in the basic graph and just throw out the 1, which I know is up 1, and the 3, which I know is left 3. So I have a cleaner graph, and then I'm going to go left 3, up 1. I could do y equals 1 over x, and then do a vertical stretch, and then do a reflection, but I don't want to do that. So instead, I can use this as my basic graph instead. So it'll look like the boomerang, but it might not be the exact boomerang that I was looking at in the other ones, but it should resemble a boomerang. Okay, so we're going to substitute in some values. -2, -1, 0, 1, and 2. And I'm going to substitute them into the basic graph that I'm choosing and not the original graph. So -2 over -2, that's divided by, so that's +1. 2, -2 divided by -1, that's +2. -2 divided by 0, that's undefined, and I've just been writing asymptote because that's helpful in the graph. So, but this is really called undefined, but the graph has an asymptote. And then -2 over 1, which is -2. And then -2 over 2, which is division, so that's -1. And then I'll go left 3 and up 1. And then there's the last asymptote. So this one is the vertical asymptote. I'll put it in my chart. And then my horizontal asymptote is asymptote 0. And then I move it. So let's draw that graph. Left 3, up 1. So I just need to make sure that I can go left. Up 1 shouldn't be very far. So -2, 1. -1, 2. 0 is an asymptote. And 1 is -2. 2 is -1. And the horizontal asymptote is at y equals 0, the x-axis. It still kind of looks like our boomerang. It just looks like our boomerang is in different quadrants. In my own brain, I call this a second, fourth quadrant one. I never used to call them a boomerang, but I always used to think of that. Oh, that's the second and the fourth quadrant is where those graphs are. Oh, I drew them solid. I probably should have drawn them lighter. I'm highlighting my original asymptotes just so you can see when I describe it. You don't have to highlight them. Might not be a bad idea for the future when I teach my class though. Okay, so let me know when you're where I am. Okay, so the blue one is called a vertical asymptote, and I need to move that blue one left 3 up 1. But really only the left is going to make a difference because moving the blue one up 1 doesn't do anything. So it just shows up here, left 3. Okay. And I might as well put right now vertical asymptote x equals -3. Okay. And then the yellow one, I need to move left 3 up 1. So the yellow one, I also need to move left, but left doesn't do anything. But when I go up 1, it shows up right here, up 1 from the yellow. I don't know, maybe I like highlighting the yellows. I might need to buy some highlighters so students have them in class. Okay, and then I also need to move the dots. Oh, those both look like whole number dots, so I might move them both. So left 3 up 1. Oh, that's the x-intercept. Left 3 up 1. And then keep it in this. It's not really the fourth quadrant anymore because I moved it, but I kind of think of it looking at the green lines, it's still the fourth quadrant. Okay, and then I need to move the blue one. So this dot right here, left 3 up 1, left 3 up 1. And then I still have my boomerang. I like that idea that they were calling it boomerang, one of my classes. Okay. So the blue is not the real one. The green one is the real one. The green is the final graph. And I need to list my horizontal asymptote. So my horizontal asymptote is y equals 1. And then I can write a little note over here. Vertical asymptote, our x equals a number. And horizontal asymptote, our y equals a number. So that's going to always be the case because of the vertical and the horizontal lines. Remember we said the y upside down? This y, if you flip it upside down, looks like an 8. So I think we have time for one more. Kind of cool. I like it. My mom was texting me, so I was just making sure it's not an emergency. And I'm trying to make sure that I'm more slow than usual because usually I'm speedy. Let's see. Let's do another one. Okay. So y equals 4 over x minus 3. How about we just have that one? So there's no outside. So which way should that one move it? Yes, I agree. So this is right 3. Okay, so that one's right 3. And then my basic graph is y equals, I'm kind of in my brain crossing out the -3 because I already took care of it. but I don't want to deal with the 4. I know personally because I'm a teacher, but I know it's a vertical stretch, but I don't really like doing vertical stretches in these rational function graphs. So I prefer just to leave it in my basic graph and let the table of values absorb the 4 instead. Okay. Okay, so then I'm going to make my XY chart, -2, -1, 0, 1, and 2, and then an extra row for the horizontal asymptote. And that's at 0 for the basic. When they're not basic graphs, it does look different. Okay, so this one is 4 over -2. Over means divided by, so that's -2. 4 over -1, that's divided by, so that's -4. 4 over 0, that's undefined, so we're writing asymptote. And then technically that's a vertical asymptote. And us writing this in is going to help the other problems. There's some other problems that have asymptotes that we do in a different method. So 4 over 0 is undefined. But having the number over 0 be an asymptote is very typical for graphs. Okay, 4 over 1 is 4, because remember it's divided by. And 4 over 2 is divided by, so that's 2. Okay, let's write asymptote here. The basic graph, if you have any number, I'll call it A over X. If you have A over X, your basics have horizontal and vertical. I'll put this horizontal asymptote is Y equals 0. And then your vertical asymptote is X equals 0. This is for basic graphs that look like this. So we're having these as our basics, our basic graphs. And I'm going to go right 3. Okay, so I just need to make sure I have a graph that I can move right 3. So -2, and I like to put the asymptotes in first, but sometimes you put them in after because you don't think about it until later. You're like, oh shoot, I need more points, but really you just need asymptote. -1, -4, 0 asymptote. Okay, it's this line right here. And then 1, 4, 2, 2. Okay, it looks the same, just looks a little taller. But I do need to know where that other asymptote is. And so the other asymptote is here on the x-axis. Oops. Let's try to draw it in dashed. And then I have my horizontal asymptote at 0, my vertical asymptote at x equals 0. And I need to move my asymptotes to the right 3. So my yellow one, when I move it to the right 3, doesn't really move. And my blue one, when I move it right 3, my highlighted blue one, turns out to be over here, 3. And then, I mean, my new yellow one is just the same as my old yellow one because I didn't move it up. I just moved it to the right. And so to the right, it looks the same. Okay, and then I have to move my dots. Okay, so my each point is which way? I forgot. Right 3. Right 3. Right 3. Right 3. Right 3. So my horizontal asymptote didn't move, so it's still at y equals 0. And my vertical asymptote moved, so my vertical asymptote is right here. And it has to be x equals a number. And so the number would be 3 since I moved it to the right 3. We do have 7 minutes left, so I'm going to show how to find x and y intercepts. And we'll do more of that in the next video. So I'm curious. The reason why is I want to know in this last graph, I want to know where it crosses the y-axis. So that's what made me think to ask what the x and the y intercepts are. So we'll do the x and the y intercepts on the graph that I just did, and then I'll show you another one if I have time. So let's talk about x-intercept and y-intercept. And maybe on Thursday, I'll have some problems on specifically finding the x and the y-intercept. Okay, so I have y equals 4 over x minus 3. And I need to find the x-intercept. And then separately, I'm going to find the y-intercept. Okay, so do you remember how to find an x-intercept? So type in the chat if you remember how to find an x-intercept. An x-intercept. An x-intercept. You substitute in something. Something equals something. Yeah, you plug in y equals, and you plug in y equals 0. Plugging in y equals 0 gives you the x-intercept, and plugging in x equals 0 gives you the y-intercept. Okay, so let's plug in y equals 0. So 0 in for y. And then this one, you'll plug in 0 for x. Now, you have to find the x and the y-intercepts from the original. The original, not the basic graph. Okay. I kind of like the y-intercept better. It's 4 divided by -3, which is -4 over 3. So if I write that as a coordinate, I said that x was 0, and then y is -4/3. So that is the y-intercept. So what is that, like -1 1/3? I just want to check for my graph. Hey, that's not bad. My green graph looks like it hits -1 and then a little. So that looks good. My red circle looks like it's -1 1/3. Okay. And then the x-intercept, you're going to put a 1 underneath the 0, and then you're going to cross multiply. So 1 times 4 and 0 times x minus 3. Usually we don't show that step. Usually people just multiply it. Oh, that's annoying. That's 0. Well, 4 doesn't equal 0, so this is not possible. So I guess there's no x-intercept. Huh. Let's check. Let's check my picture. Yeah, my green graph never hits the x-axis. So I'm going to agree with that. No x-intercept. Let me move that up so you see it. So there's no x-intercept. Okay, so that's the idea. We have to put in the y equals 0, the x equals 0, and then we have to solve the equations. Okay, so let me list what the homework is. Okay, so this is homework. I believe for your class we're on DL9. Okay, DL9, and the instructions are graph using basic graphs and transformations. Oops, transformations. Also, label, we'll put label the equations of the asymptotes. Okay. Here we go. Yeah, I wrote that one twice. Probably should make that so only that shows. Okay, there we go. I was repeating that just so it was in a better spot for me to post. Cool. I'm gonna stop the recording.